Well, today we'll be learning how to calculate 95% confidence interval for sample mean. So let's, specify some notations. Let sample mean be represented by M, sample standard deviation represented by SD, and sample size represented by N. Okay, um, should be, should not be news here. And then we define, or the formula, right, for 95% confidence interval for sample mean will be this point estimate, right, sample mean, plus or minus the z-score associated with the 95% confidence level times the standard error for sample mean, right? We know the standard deviation. Turns out that standard error for sample mean will be standard deviation divided by the square root of sample size. Okay, so this actually is very much uh, uh, like the confidence, 95% confidence interval for sample proportions, right? Sample proportions times plus or minus the z-score associated with 95% confidence level times the ratio here, right? So the only difference is is the standard errors are different, right? So this part is the same, right? The only difference is the numerator here, right? The numerator for the standard error for sample mean is standard deviation, um, and this is actually the standard deviation for sample proportions. Okay, so it's very much the same. Okay, all right. Now we can look at an example, right? From a sample, for example, of 500 Honolulu citizens, the mean response on a 7-point scale on gun control is 4.2, right? On this particular scale, 4 representing neutral, doesn't have an opinion, and the standard deviation is 3. So we know that immediately we can draw some quick guesses. For example, we can perform a point estimate, right, using the sample mean, right? Because the mean response of this 500 sample is 4.2, so that means we can make a guess that the population mean or the average population attitude toward gun control should be around 4.2. But of course, right, there will be uncertainties because if you draw a different sample of a sample of different 500 Honolulu citizens, you might get a different mean score, right? So there will be uncertainties, and we need to capture or quantify that uncertainty. And to do that, we can calculate the 95% confidence interval. Okay? We pretty much have everything here, every piece of information that we need, and let's figure this out together. So this is the question, and this is our formula, right? And then we can start to calculate the 95% confidence interval for sample mean. So here is what we know, right? The sample mean M is 4.2, SD is 3, sample size is 500, and the z-score associated with the 95% confidence level is 2. Now we have everything, okay? So now we can plug in the numbers and start to do the calculation. So 95% confidence interval will equal to 4.2, right? Plus or minus the z-score associated with 95% confidence interval. We know that's 2, and times SD is 3, right? Divided by the square root of sample size 500. Fairly straightforward, isn't it? Okay, so we have 4.2 plus minus 2 times we can actually 2 times 3, that's 6. Okay, 6 divided by 500. Okay, so now you can start to use your calculators, right, to do the calculation. So it will be, let's say, okay, from my calculation, this part will be 4.2 plus or minus 0.27. Okay, so then we'll have the confidence interval. The lower bound will be 4.2 minus 0.27. Okay, so 4.2 minus 0.27, we have 3.93. Then what about 4.2 plus 0.27? That will be 4.47. Okay, so this should be our confidence, 95% confidence interval for this particular sample mean. Let's check the answers. Okay, close enough, right? So the standard error should be 0.13, right? That's close because 2 times 0.13 is 0.26, right? Well, because of rounding errors, right? I have here 0.27. That's close enough, and indeed, right, my answer here is very close to what I got, right, on the slides. So yeah, so the 95% confidence interval for this point estimate of sample mean is 3.94 to 4.46. Okay, so that means at 95% confidence level, right, the population mean can take any value from 3.94 to 4.47. We don't know an exact amount because we don't know an exact value because we don't study the population, but we have a fairly good guess, right? So if we draw 100 sample, right, then 95 out of 100 samples will have mean scores that's bounded by 3.94 to 4.46. Okay, so that's another way to understand the sentence. 95 out of the 100 samples that we draw from the population would have a mean that's bounded by 3.94 to 4.46. Okay? Okay, so now we can ask our question, right? So given this confidence interval, shall we conclude that, Honolulu citizens is in favor of or are opposing gun control? Okay? Given this is the scale, right? So if we look at a point estimate, we might tend to conclude because 4.2 is larger than 4 is to the right of 4, right, in the direction of 7 in favor. So we tend to say, well, based on this point estimate, we want to say that Honolulu citizens should be in favor of gun control. But we said, right, before, this point estimate, useful as it is actually not uncertain, right? There will be uncertainties about this point estimate because if we draw a different sample, we'll have a different value, right? And by doing the calculation, we know that the fluctuation or certainty is bounded by this interval. That is, the average sort of attitude toward gun control can be as low as 3.93 and can be as high as 4.47, right? Then of course, if the value is above 4, then that means the population has an average attitude that's in favor of gun control. But critically, because the average attitude could also be as low as 3.93, which is below neutral point in the direction of opposition. So that means this population could also be against gun control. right? So in other words, because this 95% confidence interval includes the neutral point 4, right? So the sample mean or the point estimate of 4.2 is not meaningfully different from the neutral point and 95% confidence level. That is, in terms of absolute value, of course, 4.2 is different from 4. But statistically, right, the difference of zero point 0.2 can be as well be caused by random samples, right? If you draw a different sample, you could very well have a sample mean of 4 or 3.9 or 4.2, right? You don't know, right? So that's why we say, 4.2 statistically is not different from 4. So then we cannot draw the conclusion that the average attitude toward gun control is in favor of the issue. Okay. Okay, so if we change the number by a little bit, okay, to these numbers, what should be the 95% confidence interval? Okay, so you should probably do this by yourself. So you should pause right now before listening to my explanation. Okay? Alright, so imagine you have paused and you have worked out your answer. So let's check your answer together. So we know the confidence interval formula for 95% is sample mean plus minus the z-score associated with 95% confidence interval times the standard error, right? It will be SD divided by n, sample size, square root of sample size. So easy, we just plug in the numbers. So the confidence interval will be 4.2 plus or minus. We know z for 95% confidence level will be 2, right? Times, what is SD? SD is 1.5. What is n? N is 500, but don't forget to take the square root of it. So it will be 500. Okay, easy enough, right? Okay, so just do the calculation. What is it? Okay, so according to my calculation, the standard error is about 0.07. Okay, it's 0.067, but to round it up, it will be 0.07. So this equals 4.2 plus minus 2 times 0.07 is 0.14. Okay, so that means the lower bound of this interval will be 4.2 minus 0.14. Okay, so 4.2 minus 0.14, that will be 4.06. The upper bound will be 4.2 plus 0.14. Okay, so that will be 4.34. Okay, so there we go. This is our 95% confidence interval for this particular point estimate of sample mean or population mean. Okay, so now I can ask you, okay, given this confidence interval, can we say that the average opinion of this population is in favor of gun control? Right, so this is our scale, right? So 1 is oppose. 4, as we say, is neutral, right? It's neutral. And 7 is in favor of. Favor. Okay? So given the scale and given this confidence interval at 95%, can we say that at 95% the average opinion of the population favors gun control? Can we say that? Think about it. Well, yes, you can, right? Because true, there will be fluctuations, right, in the sample mean as we draw different samples from the population. But um, despite the fluctuation, right, the sample mean can be as low as 4.06, which is still greater than 4, right, which is the neutral point. That means, sure, it can be very low as 4.06, but still is in the direction of favoring gun control. That's why we can um, conclude, right, that a 95% confidence level, the average opinion of this population favors gun control. Okay? So now we can have a rule of thumb, right? So if 95% confidence interval for a sample proportion or sample mean or any kind of statistics, right, does not include the reference value. It could be 50%, which is, the point that separates, majority from minority, right? Or the neutral point, or 0 point, whatever, right? So if this interval does not include the reference value, then we conclude, right? So that a sample proportion, mean, any statistic, um, does not conclude, right? So if the interval does not include the reference value, then our sample estimate will be meaningfully different from the reference value at 95% level. Okay. Um, that means the difference is real, right? It's not by chance. It's not because of the sampling procedure. In contrast, right, if the 95% confidence level interval for sample proportion mean or any statistics includes the reference value, right? 0, the neutral point at a attitude scale, or 50%, right? Then the sample proportion, mean correlation, mean differences, the point estimate does not differ, typo here, does not differ from the reference value at 95% level. Okay? That means the difference, right? Of course, for example, 4.2 is, in terms of value, right, different from 4, or, the proportion of 52% is, by value, different from 50%. But because, right, at the statistical level, the interval includes the reference value. So we conclude that our point estimate, a sample proportion, a sample mean, is not statistically or not meaningfully different from the reference value, right? The difference is by chance, right? It's not real. Okay? All right, so that is pretty much about the confidence interval, right? The part on confidence interval. So, as I said, this is a rather new idea, I assume. The bottom line, I should say, is you should know how to calculate confidence, 95% confidence intervals for sample proportion and sample mean. And you should be able to draw conclusions such as, is the majority of the population in favor of the issue? Is the majority of the population prefer a particular candidate, or is the population average opinion favors the issue, right? As long as you are capable of drawing that conclusion based on the confidence intervals, which you know how to calculate, you should be fine.